We now move on to factoring perfect square trinomials. And the patterns are going to look like this: a squared plus 2ab plus b squared. Now I will tell you right now, or a squared minus 2ab plus b squared. But what I was going to tell you was that it's easy to recognize that the first term and the last term are going to be perfect squares. You have to do a little digging to figure out how the middle term is related to 2ab, and I'll show you that in just a little bit. But if you end up seeing a squared plus 2ab plus b squared, that's going to factor to be a plus b, the quantity squared. If you see a squared minus 2ab plus b squared, that's going to factor to be a minus b, the quantity squared. Notice when you square positive b or square a negative b, you're always going to end up with a plus b squared. The determination of this middle term being positive or negative is based off of whether you have a sum or a difference of your within your binomial. And again, remember, this is the simplified version. Factoring is not simplifying. Okay, if you saw a perfect square trinomial, you would leave it be. It's perfectly simplified the way it is. The only reason you would put it in this factored form is if you were directed to factor, or if it was necessary for you to factor to do something else in the problem. So let's take a look at our first example here. And we are given the problem n squared plus 8n plus 16, and we're asked to factor it. So when we factor n squared plus 8n plus 16, we recognize n squared is a perfect square, 16 is a perfect square. 16 is the square of 4. And notice, n squared is the square of n. If you take 4 times n, you get 4n. If you double it, you get 8n. So that's how you can recognize if it's a perfect square trinomial, by actually doing a little bit of the work. So whenever we factor this, we're going to end up with the n first, the 4 second, and it's plus 8n, so it's going to be plus in between, n squared. Done. There's nothing more to it than that. Let's take a look at our second example, where we have 4x squared plus 12x plus 9. And again, we're supposed to do this in a factored state, and it is a perfect square trinomial, as all the examples are going to be. But notice 4x squared is a perfect square because you get it from squaring 2x. 9 is a perfect square because you get it from squaring 3. If you take 2x times 3, 2x times 3 is 6x, and you double it, you get 12x. That verifies that this is a perfect square trinomial. And we're going to factor it to be a binomial squared. And what do you square to get that? 2x. What do you square to get that? 3. That's a positive, so we're going to put a positive right there. If you want to double check, multiply and double, you'll see that you do get that 12x. Let's go to the third example. We have 100x squared minus 170x plus 49. And I think that should be 140x, not 170x. Alright, so let's take a look here. Now, that's a perfect square, that's a perfect square. What do you square to get 100x squared? You square 10x. What do you square to get 49? You get 7. And if you multiply those, you get 70x, and if you double it, you get 140x. So this is going to be, in its factored state, 10x and 7. And since that says minus, we're going to put a minus right there, and it's squared. There you go. The last example that we have is x squared plus 2/3 x plus 1/9. And I agree, fractions make this look a little less agreeable to us, but x squared is from squaring x 1/9 is from squaring 1/3. If you square 1/3, you square the numerator, square the denominator, you'll get your 1/9. If you multiply these two, you'll get 1/3 x, and if you double it, you get 2/3 x. So this is a perfect squared trinomial, which will factor to be x and a 1/3, and since it says plus, we'll say plus, and it's squared. So there's example 4.